Let's explore some common JavaScript mistakes, understand the error patterns, and learn some best practices. In this video, we will learn common JavaScript pitfalls and how to avoid them. We will also master debugging strategies and prevention techniques. This will help you write more robust and maintainable JavaScript code. Let's start with some common syntax mistakes. One frequent error is missing semicolons. Although JavaScript has automatic semicolon insertion, relying on it can lead to unexpected behavior in certain cases. For example, look at the code snippet where we have two variable declarations and a console log statement without semicolons. While this may work, it's better to add semicolons to avoid any confusion. Here is the corrected code with semicolons after each statement. Another common mistake is incorrect string concatenation. For instance, if you try to use a single quote within a single quoted string, it will cause a syntax error. To correct this, you need to either escape the inner single quote using a backslash, or use double quotes to define the string. Here are some more syntax pitfalls. One common mistake is bracket mismatching. Look at this function definition. Notice that the curly braces are not properly matched, and that will cause a syntax error. Here is the corrected code with proper closing brackets for both the function and the map method. Another syntax issue is with object literal syntax. In JavaScript object literals, commas are required between the properties. Missing or having an extra comma can cause syntax errors. So be sure to maintain proper comma usage inside object literals. Let us now delve into scope and variable declaration mistakes. Variable hoisting is a common source of confusion. When using the keyword var, variables are hoisted to the top of their scope. As a result, they can be accessed before they are declared. Look at this example. The console log statement outputs undefined, as the counter variable is accessed before its declaration. Using let, which is a better way to declare variables, prevents hoisting. In this case, the console log statement gives the right value after the variable declaration. Always declare variables before using them to avoid unexpected results. Block scope is another important concept. Variables declared with var do not respect block scope, while variables declared with let do respect it. Look at the first code example. The console log statement outputs 10 even though the x variable is declared inside an if block. But when we use let to declare x, the console log statement gives a reference error since x is not available outside of the if block. Therefore, use let or const for block scope declarations to maintain proper encapsulation. Now let's discuss some common closure pitfalls. A frequent mistake occurs with loop variables inside closures. Consider a for loop that uses the var keyword and then a set timeout function inside it. The console log prints 3 times as the variable I is accessed by reference after the loop is completed, and has the value of 3. To fix this issue, replace the var keyword with let. Let creates a new binding for each iteration, resulting in the desired output, that is 0, 1, and 2. This happens because let creates a new variable in each loop iteration. Another closure pitfall occurs with event handler functions. If you use a regular function, the this keyword inside the handler will not refer to the current counter object. To fix this, use an arrow function. Arrow functions preserve the lexical this binding, making them ideal for event handlers and callbacks. Let's now shift our focus to asynchronous error handling mistakes. One common mistake is to have unhandled promise rejections. If you do not provide a catch method, any error that occurs in the promise chain could go unhandled. To handle errors in promises, make sure to include the catch method. For asynchronous functions that use async and await, use try-catch blocks to handle the errors. This ensures that all errors during an asynchronous operation are handled. Always include error handling for promises and async functions to prevent unhandled rejections. Now let us look at some asynchronous timing mistakes. Race conditions often occur when you access data from an asynchronous operation before the operation is completed. In the first code snippet, The console log statement outputs undefined because the data variable is being accessed before it has been populated by the fetch call. To fix this issue, the console log statement should be inside the then method of the promise to ensure it gets printed only after the promise is resolved. Another common mistake happens with multiple asynchronous operations. If you call multiple async operations using the await keyword sequentially, each operation will wait for the previous one to complete. This could be slow and inefficient. To do these operations concurrently, use promise.all, which can significantly improve performance. Let's explore some effective debugging techniques. One such technique is using advanced console methods. For example, you can use console.trace to trace the call stack and see where your code is being executed. You can also group related logs with console group and console group end. You can also time various operations using console.time and console.timeEnd. Another useful technique is the debugger statement. You can put this statement inside your code to create a breakpoint so that you can pause the execution at any time. This will allow you to inspect variables' scope and call stack in real time and understand what is going on with your code. Let us look at some advanced debugging tools. Source maps are very useful when debugging minified code. Source maps are created with a bundler tool like Webpack, which map your minified code back to the original source code. This is very helpful when debugging in production environment. You can also use the browser's performance and memory panels. For example, you can profile the performance of your code, look for memory leaks, and identify bottlenecks. These tools give you deeper insights into your code's behavior and performance. Let's summarize some best practices. For code quality, use strict mode and modern JavaScript features like ES-Next modules. Always have comprehensive error handling for asynchronous operations, and write unit test for all the critical parts of your code. For development workflow, always use linting tools like ESLint with strict configuration. Always have code reviews and automated testing in continuous integration and continuous delivery. And maintain comprehensive documentation and type definitions for your project. By following these best practices, you can write more robust, maintainable, and high-quality JavaScript code. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.